So, so along with the linked list array, we discussed two more ADT as data type. One is the stack, another is queue. And so the queue is first in, first out. The order in which they are inserted, the elements are inserted in the same order, the elements are deleted. Similarly, for stack, it is last in, first out. The element which inserted last will be deleted first. Okay, so theoretically, I think the idea is clear diagrammatically. I have also the code here, so I will share the entire presentation with you. You can try the code by yourself. You can take the help from here and write your own code, and then let me know if you have any difficulties. Okay, now whether it is a stack or queue, you can define your stack and queue or implement your stack and queue in two different ways. The simplest way of implementing stack is array, or similarly for queue is array, because array is also a data structure. So you can use array for implementing your stack or queue. Similarly, you can use your linked list to do the same thing. And of course, as you know, that there are some pros and cons for both the implementations. If you go for array, there are some advantages that you will be getting. There are some disadvantages that also you will be getting. So using arrays and using linked list. So insert an element. So these are the functions. Enqueue. Enqueue is the function which is called inserting an element in the queue, and dequeue is removing an element from the queue. And create a new queue. You are creating the entire queue stuff. So that is called create function. Where you have queue, there is a question of checking whether it is an empty queue or full queue, or there is an element or not. Because sometimes it may found that you want to dequeue, you want to delete an element, but before deleting an element, you have to check whether there is an element or not. If there is no element, then you cannot delete it. So before deleting a particular element from the queue, you have to check it whether any element is there or not. This is one thing. Second thing, if you go for array implementations, then as you know that for array, the size is fixed. You have to declare the size of the array at the beginning. So size is fixed. So before inserting any new element in the array, you have to check whether your queue is filled up or not. That means if your queue is empty, there is a space to insert new element or not, that you have to check. Then only you can insert new element. Sometimes there is a need to check how many elements are there in the queue. Return the number of elements in the queue. So these are the basic operations that are performed in queue implementations. Enqueue, dequeue, create, isEmpty, size. So enqueue will take a new element to be inserted. Dequeue, it will delete an element and will return the result which element has been deleted. Create, a queue will be created and it will return a pointer such that you can further go on inserting new element. IsEmpty is a boolean, either it will return 1 or 0. That means whether the queue is empty or not. Size, it will return an integer value. Similarly, stack implementation using array and linked list. stack using array. So in a stack, there are two operations. Just like in queue, you have enqueue and dequeue. In stack, you have two operations, push and pop. So there is a pointer called, top. The top will always point to the top of the queue. Top will always point to the top of the queue. Whenever there is a new element inserted in the stack, so if you insert a new element, the top will point to here. The new top will be this. If you insert another element, the new top will be this. Similarly, there are so many elements. If you delete this, the new top will be next, like this way. So linked list implementation of this. So top will point to the first node. Push operation. You are inserting new element. So the new element is inserted, and the new top will be known as, this node will be known as new top. Because you are inserting one more element, so the new top will be the new node. Pop operations. You want to delete an element from the linked list, from the stack. So last in, first out. The element which inserted last will be deleted first. So here, this is the element which inserted last. So this node will be deleted, and the new top will be this. This is my new. So mind it, for stack implementations, insertion and deletion, there is a push and pop. Both the operation takes place at one end of the list. So only the top pointer will be changed. If you insert a new element, top will be the new top will be the new element. If you delete an element, the new top will be the next element. In the array implementation, you declare an array size, array of fixed size, which determines the maximum size of the stack. That means if you go for array implementation, then at the beginning, you need to give the fixed size. That will be the maximum size of the stack. Keep variable which always points to the top of the stack. Contains the array index as the top, because array you have array index. So that can point to the top. In the linked list implementation, we have the flexibility. We don't need to give the maximum size at the beginning. As and when the new elements are coming, you can create a node and you can insert it. So maintain the stack as linked list. A pointer variable always points to the top. So the first element of the linked list is considered as the stack top. So at the code level, you can see this thing. So stack implementation for array as well as linked list. For array, there is no questions of pointer. You have to declare the maximum size, and the top will point to the array index. On the other hand, when you go for linked list implementation, the top will point to the pointer or the address of the last node, the top node. In array, you have to always give the maximum size. You have to declare the maximum size. You cannot go beyond that. And also, when you declare the maximum size as 100, this space will be reserved in your memory, which you cannot reuse for other program. But here, as you are not declaring the maximum size, as and when required, the memory will be reserved. That is the advantage. The second case is, you declare the maximum size as 100. You have declared the maximum size as 100, but you cannot reach beyond 100 because there is only 100 sizes reserved. But here there is no such constraint. Similarly, for stack creation using array, is a code level design. Top points to the null here. Here you can give a -1 that denotes the top. That means there is no, I mean that denotes the last element, top element. So this is the code for pushing an element in the stack. Similarly for the linked list, copying an element from the stack, this is the code. So before pop, you need to check whether there is an element or not. That means this is called underflow, stack underflow. That means if there is no element in the stack, then you cannot delete. You cannot pop. So before doing the pop operation, you need to check whether there is element or not. If there is element, then only you can go for pop operation. Similarly, for linked list, you have to check if the top is null, that means there is no element, then stack is empty or underflow. It's called stack empty or stack underflow. So stack empty and stack underflow are the same thing. Else it will return the top node. So, and there is another function that we discuss is empty. Whether there is no more, I mean, whether the stack is empty or not. I mean, there exists free space or not. But here, mind it, there is no question of to check is empty in the linked list. Why? Because in array, you have to declare the maximum size. So if you reach to the maximum size, then the is empty is, it will return a negative answer. That means false answer. But in linked list, there is no question of is empty. Whenever there is a requirement of putting a new element, you just reserve a space to insert it. So is empty is only applicable only for array implementation, not for linked list implementation. As such, you don't need to check. Just always you will get the some element space. Similarly, for stacks maximum size, as you declare in maximum size in array, so whether your stack is full or not, you can check it. But here, not required for linked list implementation, because there is no question of upper limit. Whenever you need to keep an element, just keep on adding, keep on adding. Okay, so example of the main functions for array and for linked list. Okay, so I think this is up to for today. So tomorrow I will be going to the queue implementation using linked list.
Okay, sir. Thank you. Thank you for the session. If anyone have any question regarding this,
I will be happy to answer.
You can ask, unmute yourself and ask the question to sir. If anyone has any question.
Or even if you have the questions in at your home, you can jot down the questions. Tomorrow we can have a discussion with this thing. Okay, so there is no harm about it that you have to ask the question right now only. You can jot down the questions you can have a discussion tomorrow also, or if you are have the question now, you can discuss now also. So both is okay.
So,
কিছু question থাকে?
anyone has any question? Okay. I think, sir, there no one has any question.
Okay.
So thank you for the session, and we will again meet tomorrow
Join
at
tomorrow.
10 a.m. and we
Sure.
will have a 4th session like same, which
It's okay. Good.
today has also. So we will meet next day tomorrow for upcoming session. Thank you.
Sure. Thank you.
Thank
Thank you.
you.
Thank you, sir.
Thank you everyone for the session. I am ending the meeting here.
Sure.
Okay.